Hello class, this is a video tutorial on modeling quadratic equations. Many scenarios can be modeled using a quadratic equation. By understanding the key features, we can predict values from various scenarios. However, we should be aware of the context and limitations of what the equation is modeling. So, let's get straight to one example here. The area of a rectangular garden of length x is a equals 6x minus x squared. Graph the equation of the area using a table of values. Well, nothing more straightforward than that. So let's get straight to doing a table of values. Here we go. So we're substituting 0 in for both x's here. So it's going to be 6 times 0 minus 0 squared. Very straightforward. Gives us 0. Substituting 1 into x now. This will give me 6 times 1 minus 1 squared. Gives me 5. Continuing like this, 6 times 2 minus 2, put that in brackets, minus 2 squared gives me 8. 6 times 3 minus 3 squared gives me 9. This pattern will just keep on going until we finish the table of values here. Gives me 8 once again. We can see that we found the axis of symmetry because it's gone up and then back down. So I can tell that the next value is going to be 5 because this is matching the progress that's going on from left to right. So my prediction is that that's going to be 5. So let's substitute it in. 6 times 5 minus 5 squared. Also 5. This will give me 0. And now is a value that we don't know. So let's substitute it in. 6 times 7 minus 7 squared. That's giving me negative 7. Now, plotting this onto a Cartesian plane, let's draw one up, or in my case, let me just copy paste it. Let's copy paste it from here. Oops. I only need about this much. Oops. Actually, you know what? Let's just take the entire thing, because why not? There we are. Let's paste this in. There we go. So let's mark our points. Let's make these 2, 4, 6, 8. Same goes for going upwards. 2, 4, 6, 8. And now let's mark the points that we have. 0 is going to be an area of 0. So it's going to be 0, 0. 1 is going to be an area of 5. So when x equals 1, the area will be 5. When x equals 2, the area is 8. So 2, 8, 3, 9. So 3, 9, 4, 8. 4, 8, 5, 5, so 5, 5, 6, 0, and 7, negative 7. Let me write that in. Negative 2, negative 4, 7, negative 7. Oops, that should have been 8. 7, negative 7 down here. So graphing this, we will get, oops, this is as neat as I can do it by hand. There we are. And even though it stops, we can continue like this, right? So estimate the area of the garden when its length is 4.5. Okay. Well, actually, I prepared much more from this. Even though we've graphed it ourselves, it's best to be able to use an actual graph done using a graphic calculator. Whoops. Copy this. Should be copied. Paste. That's what we want. Oops. Let's minimize this first so we can make space for the actual one. There we are. So if ever you do a question like this, it's best to do it using the actual graph, like graphing it yourself, but then using a graphing calculator to work on with the rest of the question. Okay, so here we go. Estimate the area of the garden when its length is 4.5. So when its length is 4.5, so 4.5 on the graph is about here, going all the way up to when it touches. We go all the way across, and we're going to estimate what that value is, because this is the area here. So let's guess that's 6, 6.5, and then 7. I can see that this is about 6.75. That's my guess. So my guess is an area of 6.75 meters. Now we can do this graphically. However, we can utilize the equation itself and just substitute the value that we need. So in this case, we're going to substitute 4.5 in for x. So let's do that. So 6 times 4.5 minus 4.5 squared. 6 times 4.5 minus 4, that's going to have an error, minus 4.5 squared. Would you look at that? My estimation skills were amazing. Meters squared. What is, let's move this out of the way. What is the maximum area of the garden? In this case, if we recall from our previous videos, the maximum refers to the vertex of the parabola. So in this case, the maximum area here is very clearly here. It's 9. So the maximum area is 9 meter squared. Okay. Oops, that's the wrong bit. I should have put it here. 9 meters squared. What is the garden length in order to have a maximum area? Okay, so let's read what this question says. The garden length, as we've seen, is referring to x. So when it says what is the garden length, so it wants an x solution, so x is equal to, we don't know yet, in order to have a maximum area. Well, the area here is 9. What x value gives me an area of 9? In this case, it's very clearly going to be 3. So in this case, x equals 3. Now here's the last question that we have about this question. What limitations does this quadratic model have? Well, this is the quadratic that we had, and we graphed from 0 to 0 to 7, right? And we only saw this much here. However, if we consider what this actually means, if area is along the y-axis, that means this here is an area of 9. But what does it mean if the area is below the x-axis? So in this case, an area of, well, let's take a look. When it says 7 here, the area equals -7. How is it possible to have an area that is negative? Okay, so in this case, it's not possible to have an area that is negative. So the limitations of this model end here. Oops, sorry, let me get this smaller. The limitations of the model is that it cannot go any further below 0, and it can't go further than 6. So we can write that the limitations of this, the model, is limited at x equals 0 and x equals 6 as anything, any value beyond those, beyond these listed, beyond those results, beyond those result in negative areas. Negative area, which is impossible. Okay, so I hope that gave you an insight. Sorry, didn't answer this. 3. So I hope this gave you an insight into using quadratic equations as a model for real scenarios, as well as understanding how to read the graph and the limitations that these models have. Hope to see you in the next video. Best of luck.